Okay, so for lesson 14, you're going to find areas by decomposing into rectangles or completing figures to form rectangles. So notice it says areas with an S, so we're going to be working with rectangles that have more than one area. So let's take a look at what we're going to do. All right, so this first one on the concept development says, Fanny has a piece of fabric 8 feet long and 5 feet wide. So you can see this piece of fabric right here, 5 feet and then 8 feet. She cuts out a rectangular piece that measures 3 feet by 2 feet. So here's this white piece that she cuts out. How many square feet of fabric does Fanny have left? Okay, so we know, because we've worked on this in a previous lesson, we're going to have to find the area of this whole piece of fabric first, and then we've got to find the area of the piece that she cut out. So then all we will have to do is take away this part from the total area to help us answer the question of how many square feet of fabric Fanny has left. Okay, so on the piece of paper in your binder, I want you to draw this right here and label it just like it's labeled on the screen. So once you have that drawn and labeled, you can push play so we can move on. Okay, so the next question says, how big is the piece that Fanny cuts out? So we're trying to find the area of this rectangle that she cut out. So find the area of this rectangle that she cut out. If you want to write it inside of it, or if you want to write it out to the side, I'll just leave that up to you. But find the area of this white piece that she cut out and push play once you have that. Okay, so we know to find the area, all you have to do is multiply the side lengths. So when you multiply 2 and 3 together, you get 6, not just 6 feet, but 6 square feet. So the area of how big the piece is that she cut out was 6 square feet. Okay, so if we know that the piece that she cut out was 6 square feet, all we have to do is take that away from the total area. And once we take that away from the total area, that's going to tell us how much she has left over. So what we need to do now is find the total area of this entire rectangle, and we know that the entire rectangle is 8 feet by 5 feet. So we know that all we're going to have to do is 8 times 5, and that will give us the area for the entire rectangle. So what I want you to do now is solve 8 times 5 to find the area for the entire rectangle, and once you have that done, you may push play. Okay, so 8 times 5 is 40 square feet, so the entire rectangle right here is 40 square feet. So now all we have to do is 40 minus 6, and that's going to tell us how much square feet of fabric she has left over. So 40 minus 6, solve that, and push play once you have that done. Okay, so 45 minus 6 gives us 34 square feet. So that tells us that she has 34 square feet of fabric left over after she cut this piece out. And you're going to see a problem like this on your problem set. So what we're going to do now is we're going to go ahead and get started on the problem set. So if you want to go ahead and get that out in front of you. All right, so we kind of did a problem like this together right before you started this lesson. And these aren't hard. You just really have to look at them closely and look at other side lengths to help you find missing side lengths, okay? So for this first one, it says find the area of each of the following figures. All figures are made up of rectangles. So it tells you that they're made up of rectangles. And one thing that we know for sure about rectangles is that the opposite sides of rectangles are equal. So that's going to help us when we're solving this. So let's look at number 1. We know that this side length of this rectangle is 2 centimeters, but we are missing this side length to be able to help us find the area of this rectangle. But when you look down here at the bottom, it tells you that from here to here is 3 centimeters. So from here to here is 3 centimeters. It also tells us from here to here is 2 centimeters. So that means from here to here is also 2 centimeters. So if this part right here is 3 centimeters and this part right here is 2 centimeters, then what is the total length of this side? should be saying 5 centimeters because 3 and 2 together gives us 5. So go ahead and label that side right there as 5 centimeters. And then down here for this other rectangle, we do have the width right here and we do have the length. So we do know the 2 side lengths for this rectangle. So on this rectangle, we're good. We don't have to solve anything or find a missing side length. So what we're going to do now is we're going to find the area of each one of these rectangles, so that way we can add those two together to find the area of this entire figure. Okay, so for this first one, we've got 2 times 5. Hopefully you know right away that 2 times 5 is 10, but it's not just 10, it's 10 square centimeters. So I want you to write that inside that rectangle right there. And then this next one, we've got side length of 3 centimeters and a side length of 3 centimeters. We're not doing anything with this 2 centimeters because this 2 centimeters was put here just to help us find this part of the top rectangle. So for this one, we're just working with 3 centimeters and 3 centimeters. So we know we're going to have to multiply 3 times 3 together to find the area of this rectangle. So 3 times 3 multiplied together is 9 square centimeters. So now we've got the area for this top rectangle and the bottom one. So to find the area of this entire figure, all we have to do is add those together just like we did in the previous lesson. So we've got 10 plus 9, and that's going to tell us what the area of this entire figure is. Hopefully you know right away that 10 times 9 is 19, so the entire figure is 19 square centimeters. So see, that's all we're doing for the most part today. You just have to really pay attention to the opposite side lengths here to help find the unknown side lengths, okay? So one thing here though that we do need to do is we need to draw a line somewhere to help us find the area of this entire thing. Okay, so for this rectangle, there's a few different ways that we could do it. Okay, we could think of it, I'm just going to show you here, we could think of this as one large rectangle, and then what we would have to do is take out this unshaded part and then find the area for the shaded part, or, let me take that away, we could make it right here, make a line like that, and find the area for this shaded part and these 2 shaded parts. So there's 2 different ways that we could do it. Okay, so okay, let's look at it. If we did it this way, we already know the side lengths for this shaded rectangle, and we already know the side lengths for this shaded rectangle, and this shaded rectangle is the exact same size as this shaded rectangle. So when we look at it this way is probably going to be easier because we already know the side lengths, and all we have to do is multiply those real quick and add all 3 of those areas up to find the total area of this figure right here. Okay, so for this one we've got 4 and 2 meters as the side length. So all we have to do is multiply 4 and 2 together to find the area of this shaded part of the figure. Oopsie. Okay, so we got 4 times 2. And then for these other ones right over here, we've got this side length as 1 meter and this side length as 1 meter. So all you have to do is 1 times 1 to find the area of that rectangle. And since this rectangle is the same size, this one is also going to be 1 times 1. So what I want you to do is I want you to find the area of each of these 3 different rectangles. And then over here out to the side is where we will write down the areas of each one, add them together to find the total area of the entire figure. So go ahead, multiply those 3, get the answers for them, add them all together so we can get the total area for this entire figure. And once you have that done, you may push play. Okay, so 4 times 2 is 8, 1 times 1 is 1, and 1 times 1 is 1. So we've got 8 and 1 and 1, which gives us a total of 10. And so it was 10 square meters for the area of that entire figure. So it's not really hard when you look at it sometimes. You just have to figure out where you want your rectangles to be at. Okay, so this one down here is just a little bit different. this says the figure below shows a small rectangle in a big rectangle. Find the area of the shaded part of the figure. So they just want to know about the shaded part. So we're not just going to do 5 times 6 to find the area for the shaded part, because this unshaded rectangle is in there and we got to take that out to find the area of just the shaded part. So we're going to have to find out what is the area of this unshaded rectangle before we do anything else. Okay, so what we're going to do here is we're going to use these that they put all on the inside here to help us find some of the side lengths for this rectangle in here. So this whole side length of this rectangle is 6 meters. Okay, so we're trying to find just this side length right here of this unshaded rectangle. So if this side right here is 1 meter and this side right here is 2 meters, that 2 and that 1 together is 3. So if I were to take these 3 meters away from this 6 meters, I will be left with what this right here is. Okay, so when you take 3 meters away from 6 meters, that gives you 3 meters. So that tells us right now that this side length of this unshaded rectangle is 3 meters. Okay, same thing that we're going to do here, we're going to try to find this side length. Okay, so this whole side length is 5 meters. So I've got 2 meters right here and 1 meter right here. So if I take this 2 and this 1 together, that gives me 3 meters. So I just need to take my 3 meters away from my 5 meters, and that will give me what this side length is. And when you take 3 away from 5, you're left with 2 meters. So that tells us right now that this side length is 2 and this side length is 3. So now that we know the missing side lengths for this unshaded rectangle, we can find the area for the unshaded rectangle. So let's just put unshaded rectangle equal, we're going to write the area for that one. Okay, and then shaded part, hold on, I lied, big rectangle equal, keep doing it wrong, and then shaded part is equal to. Okay, so that's what we're going to do. We can now find the area of the unshaded rectangle, okay, because we know that it was 2 meters and 3 meters as the side length. So just up above it, let's write 2 times 3, and that's going to help us find the area of this unshaded one. So we know that 2 times 3 is 6, so we know it's going to be 6, not just 6, but 6 square meters. Now the big rectangle, the whole thing, is 5 meters on one side and 6 meters on the other side. So we know we're going to be multiplying 5 times 6 to find the area of the big rectangle. So multiply 5 times 6 and write the area of the big rectangle right here on the line on your paper. Okay, so that's 30 square meters. So now all we have to do is take away the unshaded rectangle from the big rectangle, and we'll have left the shaded part. So if the big rectangle was 30 and the unshaded rectangle was 6, all we have to do is minus those, and that will leave us with what the shaded part, or the area of the shaded part, is. So go ahead and solve 30 minus 6 and write the area of the shaded part on your paper and push play when you have that. So we got 24 square meters because 30 minus 6 is 24. Okay, moving on to the back side, we just got 2 problems here, but you really have to picture this in your mind and get it drawn on the paper because it will help you a lot in solving these problems. So the first one says a paper rectangle has a length of 6 inches and a width of 8 inches. So we're just going to stop right there and we're going to go ahead and draw that. I want you to draw your rectangle. It kind of needs to pretty much look like what this is talking about. Okay, it says it has a length of 6 inches, so this would be the length side of the rectangle. So I want you to put 6 inches right there. And then it says the width is 8 inches, so this side is the width of the rectangle, so I want you to put 8 inches right there. Okay, so that's the first sentence of what they're talking about. A square with a side length of 3 inches was cut out. So let's go in here and let's draw us a square inside of it. Doesn't matter where, but a square. Okay. It said that the square had a side length of 3 inches, so we're just going to put 3 inches right here on the side length. Now, we know that with rectangles that opposite sides are equal on a rectangle, but we know with a square that all of the sides of a square are the same length. So if this side length is 3 inches, so is this side length, and so is this side length, and so is this side length. So it's going to be easy to find the area of this square because all of the side lengths are 3 inches. So the question is, what is the area of the remaining paper? So they took this square right here and they cut it out. So we're going to have to know the area for the whole rectangle, and we're going to have to know the area for this square. So that way we can take the area of this square and minus it from the total area, and that will leave us with what the area of the remaining part of the paper is. Okay, so I'm going to kind of do what we just did right here. We've got big rectangle. That's going to be equal to an area. We've got square. That's going to be equal to an area. And then we've got the remaining paper. So I want you to write those 3 down on your paper. Push pause if you need to do that, and push play whenever you have it written down. Okay, so we need to find the area of the big rectangle. The big rectangle is 6 inches by 8 inches. So I want you to put that just right above where it says big rectangle, and what I want you to go ahead and do is I want you to multiply 6 and 8 together to find the area of this big rectangle, and then write that area down right here on this space of your paper. So once you've multiplied that together and wrote the area down, you may push play to check it. Okay, so 6 times 8 is 48, and it's 48 square inches, so make sure you put your square inches right there. And now the square. We know one side length is 3, so that means all side lengths are 3, so we are just going to do 3 times 3. So I want you to find the area of the square and write that down right here on your paper, and push play when you're ready to check it. Okay, so 3 times 3 is 9, so the area of the square is 9 square inches. So all we have to do to find the area of what is left over after they cut out this square is to take the total area, which was 48, and take 9 away from that because that was the area of the square. And once you've subtracted that, that's going to give you the area of the remaining part of the paper. So do 48 minus 9 and write the area right here on your paper. Okay, so whenever you do 48 minus 9, you are left with 39, so the area is 39 square feet for the not square feet, whoopsie, square inches. Okay, so really thinking about drawing it, and that really helps you solve problems like this, and it's going to help us with the next one as well. Tila and Evan both have paper rectangles measuring 6 centimeters by 9 centimeters. So there's 2 people here. So we're going to draw 2 rectangles. They're both 6 centimeters by 9 centimeters. So you got to make it look like it's 6 centimeters by 9 centimeters. So you need to draw 2 of them on your paper, and we are going to label the side length. If I can get it to move. Okay. We've got 6 centimeters and we've got 9 centimeters. So one side is 6 centimeters, one side is 9 centimeters for both of them. So get yours labeled, and then we'll continue reading the rest. If you need to push pause to get it drawn and labeled, you can do that now. Okay, so it says Tila cuts a 3 centimeters by 4 centimeter rectangle out of hers. So we'll say this first one is Tila's. So we need to draw a 3 by 4 rectangle that she's going to cut out, and we're going to label one side 3 centimeters and we're going to label one side 4 centimeters. So definitely drawing exactly what this is telling us. And then it says Evan cuts out a 2 centimeter by 6 centimeters out of his. Okay, so now we need to draw that in Evans. This side was 2 centimeters and this side was 6 centimeters. Okay, so this is exactly what we just did up here on the top, but we're working with 2 rectangles. This says Tila says she has more paper left over, and then it says Evan says they have the same amount. Who is correct? Show your work below. Notice it doesn't say to explain your answer, but it says show your work, and you just have to put who is correct. So our work is going to kind of be what we just did. So what I want you to do is I want you to, under both of these, put big rectangle, put down what that area is equal to, and then put small rectangle, what that is going to be equal to, and then we're going to put leftover, because that's what we're talking about, how much they have left over and what that is equal to. And we know in order to find what is left over, we're going to have to take away the small rectangle from the big rectangle's area. Okay, so we're going to write that underneath both of these rectangles here. So if you need to push pause to get that written down underneath both of them, you can do that now. Okay, so what you're going to need to do for both of these, they both are going to have the same area for the big rectangle because they both have rectangles that are 6 centimeters by 9 centimeters. So both of their big rectangles are going to have the same area. It's just the smaller rectangles that are made up of different side lengths that you'll have to write down those area for. And then to find what is left over, you just take away the smaller rectangles area from the bigger rectangles area, and you'll get what they have left over. Now make sure you're not just putting the numbers, that you're also putting square centimeters with it. And then down here at the bottom, or somewhere over here to the side, I want you to put who was correct. Was Tyla correct because she said she had more paper? Or was Evan correct because he said they both had the same amount that was left over? So taking the steps that we just did up here, and you're going to do that right down here for both of these. Whenever you are done, you may push play to check your answer and make sure you have already answered who's correct, Tyla or Evan. Okay, so push play whenever you're ready to check your answer. Okay, so the big rectangle for both of them, you had to do 6 times 9. And 6 times 9 is 54, and we're working with centimeters here, so that's 54 square centimeters. And that's going to be the same thing for Evans as well, because they both have the same side lengths. Now for Tyla's right here, she had 3 centimeters by 4 centimeters, so that's going to be 3 times 4, and hers was 12 square centimeters. Evans was 2 by 6, so that's 2 times 6, which also equals 12 square centimeters. So what you had to do to figure out what was left over, you had to do 54 minus 12 for both of them, since their small rectangles both equaled 12 square centimeters. So just by looking at 54 minus 12 for both of them, we can already tell who's going to be correct, which is going to be Evan, because they both have 42 square centimeters left over. So out here to the side, who is correct? We're going to put Evan was correct. And I hope that you got that as well on your paper. Okay, ready for the exit ticket? Kind of like what we just did. You're not going to draw yours on a grid paper. You're going to draw yours on the exit ticket paper like we did. You're going to draw yours on an area model where you don't have all those squares in it, but make sure you're labeling the side links and showing your work on this. And once you have it done, you may bring it to me and we will go over it.